Hey, seventh graders, today's lesson is 3.4 and 3.5 metabolism, your learning targets. I can describe how an athlete's body uses molecules differently, and I can describe how blood doping works and how it alters the body's metabolism. So basically, we've been talking a lot about metabolism and how it's our body's use of molecules for energy. And specifically, we've been zoning in on cellular respiration and how we use glucose and oxygen to release energy in the body, and in that process we also create water molecules and carbon dioxide molecules, which we know we breathe out. So if you guys kind of think of us breathing in oxygen, that oxygen moving around our blood to all of our cells, and then that oxygen gets turned into carbon dioxide in cellular respiration, and then that carbon dioxide then comes back to our blood and out of our lungs. So it's kind of a reverse process there. Okay, so we've again been talking about how we make energy using glucose and oxygen. All right, moving on to your warm-up today. You have 3 questions to answer here. So first one right here, you guys will use your draw tool. In order to maintain a high level of performance, what types of food do you think an athlete should eat right before a race? Select one. So obviously in this lesson, we're really going to focus in a lot on athletes. If we know how a normal body works, how does an athlete's body function differently? Okay, so explain your reasoning, and then the energy released in cellular respiration helps an athlete perform. How do you think an athlete might be able to increase their cellular respiration? So at the end of this, you're actually going to do a little sim test to see if you could increase cellular respiration. So you guys can kind of keep an eye out for that throughout this lesson. All right, next part, we're going to take a look at athletes. So these are some predictions you guys are going to make. Oxygen molecules taken in per breath. So if we're looking at an athlete versus a normal human being, and I'm talking not like athlete who plays high school sports, but someone who performs long endurance type athletic ventures, and they've trained their whole life and they're professionals and they get paid to do this. Okay, so let's take a look at how much oxygen they breathe in a breath. So the normal athlete's body will be, you guys are either going to circle higher than, lower than, or the same as the normal healthy body results. So do you think an athlete breathes in more oxygen than a regular old human? Okay, and then explain why. This is oxygen molecules absorbed by cells. So this is oxygen that gets moved from our lungs through our bloodstream and then into our cells. So the athlete's result will be, again, higher than, lower than, or the same as the normal healthy body results, and explain. And finally, we're looking at cell respiration level. So this is the rate at which we take that oxygen and that glucose and turn it into energy. And again, that energy is going to be what fuels these athletes' bodies. So the athlete's results will be blank, the normal healthy body results, so higher than, lower than, or the same as, and then explain. Okay, before I move on, I want you guys to take a second, pause this video, and finish this section, because I'm going to give you guys a little spoiler alert. So go ahead and make those 3 predictions, and let's see if you're right. All right, so you guys should have just completed slide 3, 4, and 5, making predictions about how much oxygen is taken in per breath, amount of oxygen absorbed in the cell, and the highest cellular respiration level in an athlete versus a human. So let's go ahead and compare some data and see if you guys are right. Okay, so first little test we have here is oxygen molecules taken in per breath. You can see a healthy body takes in about 25 molecules per breath, whereas an athlete takes in about 45. Athletes generally tend to have a higher lung capacity because they've kind of trained their lungs to take in more air than we do. Okay, this test was oxygen molecules absorbed by the cells. So this is the oxygen that actually gets to our cells. We can see a normal human is 270, whereas an athlete is 350, so quite a significant difference there. And then finally, maximum cellular respiration level. You can see a normal body is 8 and the athlete is 12. So I want you guys to go ahead and just think about what those numbers mean and whether you guys were right or not with your predictions. You don't have to go back and change anything, okay? Moving on, you guys are going to use that information that you just looked at to help you with this modeling tool. So I'm going to go ahead and right click and open up this link here, and it's going to take me into this modeling tool. So what I see here is basically what a normal body looks like as far as cellular respiration. So really the part we're focusing on most is these cells in the body right here, where we have glucose and oxygen coming together to create energy. Okay, and yes, it also creates carbon dioxide and water, but really what we're going to be focusing on is just that energy production, as that's what, with an athlete, that's what we want to see the most of. Okay, so what you guys are going to do is you're going to modify this model of the regular human body to make it look like an athlete's body. That being said, if you guys need help, you guys can refer back to these 3 factors that we looked at in this data table on slide 6. Okay, your goal, show us what is happening in an athlete's body during exercise. You're going to launch the activity and you'll see the starting model is a healthy body when exercising. And what you're going to do is you're going to change this model of the starch, glucose, and oxygen molecules in a healthy body during exercise to model what happens in an athlete's body during exercise. Tip, refer to your data table to identify the differences between a healthy body and an athlete's body. You'll be revising and handing in this model later in the session. So when you guys finish up that model, you guys will screenshot it. Remember, if you're using a Chromebook, you'll hit Control Shift and then the little key above the number 6 with the rectangle and the 2 lines to the right. Okay, then you guys can click and drag. I just need this portion right here. Copy it, Control C, and paste it, Control V, right here. Okay? All right, once you guys have that done, let's move on to the next part. You have a little reading activity. So this is called blood doping messing with metabolism to win races. And this is a little bit, I don't want to say this has never been an issue before, but the main reason that this issue took spotlight was from an athlete named Lance Armstrong. And Lance Armstrong had 7 Tour de France titles. If you guys know anything about the Tour de France, it's this really long race where basically bicyclists ride all around France. Okay, you guys can look it up and see how long of a race it is. I think it's well over 1,000 miles. But anyway, you guys will learn a little bit about blood doping, and it's basically a way athletes can enhance their performance, but it's not legal in the athletic world. And so it got a lot of media attention when this 7-time Tour de France winner from America finally admitted to blood doping. And again, you guys will read about it. So go ahead, before I explain anything more, take a second, pause this video. You guys can go in, read this article. It looks a little something like this. It's not wanting to download for me right now, but you guys will see it. Go ahead, read that, and describe how blood doping affects the circulatory system's ability to carry oxygen. And then don't forget to answer this question here. So for this, you guys will need to use your draw tool, and you guys will order those 1, 2, and 3. So what's the first thing a person who is blood doping does? And then second thing, third thing. So you guys can just write on there 1, 2, 3. Obviously, that's not the correct order. So go ahead and complete that little question there. Okay? And answer this question about blood doping so you guys can kind of get a visual of what blood doping looks like. Explain what the diagram shows about how doped blood is different from normal blood. And finally, how would the amount of oxygen in the circulatory system be different in an athlete who is blood doping compared to a normal athlete? And then how would the amount of oxygen absorbed in the cells be different in an athlete who is blood doping compared to a normal athlete? So if we go back to that table on slide 6 where we talked about what an athlete's body looked like, what do you guys think if we had a third column on this? What do you guys think a blood doping individual would look like? So that's kind of what those questions are asking you there. Okay, moving on to activity 5. This is your homework for today. This is a little simulation. So your goal in this simulation is to try to get the highest cell respiration rate possible in the sim. So you guys will right click and open up this link. It will take you into the simulation right here. And then you guys kind of get to choose how you're exploring this. I would go to test maybe so you have kind of a time cap. But first, how would the amount of oxygen in this, oh shoot. I need to fix this, so we already answered those 2 questions. So you guys will just be doing your sim here. Okay? So to try to get the highest cellular respiration rate possible in the sim, note you can see the cellular respiration level in the yellow meter in live view and as the yellow line in the yellow number in the graph view. Okay, so what we're looking at here is you guys are going to come up with 3 plans, or basically tell me 3 things that you guys tested, or 3 different ways you guys tested this. So some things you guys can do is you can change what body you're using. Okay, you can change your diet. How do you guys think you can use your diet best to get cell respiration? And then your activity level, how do you guys think that plays into that? And what you guys are going to do as you run this, let me just run one normal for you guys. You guys are going to keep an eye on either this number here and look for the highest number you get. So run it for about 200 time units and observe which number you get being the highest. Or you guys could go to your graph view and pay attention to this number or just the yellow line. Okay? Both of those will kind of help you. Really, this one's probably the easiest to just look for a number. So either of those places in the live view here or in the graph view here, just watch that for the time frame in the test, and then you guys will you'll be able to see which one's your highest. So you'll come up with 3 plans. Here's plan 1. Tell me what you did in plan 2. And tell me what you did in plan 3, and then tell me what your highest cellular respiration level that you saw was in that 200 time units. Okay? And that really concludes your guys' lesson for today. However, there is an extra credit opportunity for you guys, and you guys can turn this into as much as an extra credit opportunity as you want. So there are 5 different articles for you guys to read about odd organisms and how they get the molecules they need. So your article is right here. If you open that up, it's going to take you guys into the amplifier library. This is just the introduction, so if you guys want to get to the articles, there you go, right there. So there's 5 other animals that you guys can read about there. Okay? So you guys can do as much extra credit on you if you want. If you guys wanted, you could do all 5 of these. I'm going to give you guys 2 points per each one of these that you guys read. If you guys want to do more than one, go ahead and right-click, duplicate this slide, and duplicate slide 17 as many times as you want. So if you just want to do one article for 2 points of extra credit, you don't have to duplicate anything. If you guys want to do 2 articles for 4 points extra credit, you guys can duplicate 16 and duplicate 17, and then organize them so they go in order as you guys see them there. And then again, just tell me what you guys read and answer the questions about how they're different from a human, how they're similar to a human. So that's a little extra credit opportunity for you guys. Okay, again, if you would like to do more extra credit, feel free to read more articles. Just right-click on slides 16 and 17 and duplicate each of them. Okay, again, keep them in order as you see them in 16 and 17. And then finally, do your wrap-up. Do you have any questions? Circle yes or no. If yes, type them below. If not, you guys are good to go. Hope you guys have a great day, and I'll talk to you soon.